So here is the example on kinetic energy. The equation for kinetic energy is EK equals 1/2 mv squared. That v is velocity, but it went away with the dot product, so we're just doing the magnitude of the velocity. So we'll often hear it references speed because really direction is not important in terms of energy because energy is a scalar. So let's say we have a motorcyclist. Okay. And he is traveling at let's say 10 meters per second. And he speeds up to 15 meters per second. How much work was done by the engine? Okay, so when we see work, we need to remember work is equal to change in energy. And in this case, we have this motorcyclist is speeding up. So V1 is equal to 10 meters per second, and V2 is equal to 15 meters per second. So when we do this, this change in energy is actually change in kinetic energy. So we have work is equal to change in energy, which is actually EK2 minus EK1, because we always do final minus initial to find the change. So here we go, 1/2 m V2 squared minus 1/2 m V1 squared. You can see that the 1/2 and the m are the same, so if you want to factor this out, you can, and just deal with this math in here because the numbers out in front are the same. I didn't put in the mass of the motorcyclist, but we can put the mass of the motorcyclist and the motorcycle to be 250 kilograms. Okay, and now we put in my 15 meters per second, all quantity squared, 100 meters per second, all quantity squared, and then we have that. So here, this is 125 kilograms if I do that math. And you go ahead and do this. I wouldn't be writing out all these numbers on a test, but I'm trying to show you something here. This ends up being 22,500. 110 squared is 100. Okay, times 125. It's a great big number. And what happened to my units? Meters squared per second squared. Is that a joule? Well, that's a kilogram. Meter per second squared times a meter. That's a newton, that's a meter, therefore it is a joule. Let's put this in scientific notation. Okay, there's 3, 6. That's not a decimal. And that is a joule. Be really careful when doing this, because these squares have to happen first, and you should remind yourself and prove it to yourself that a squared plus b squared does not equal a plus b squared, or vice versa. Okay, that was something we did in grade 10. We can talk about that on Monday. And there's your example for kinetic energy.